Welcome to the Shika Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. The topic of this video is ABS, anti-lock brake. As you are well aware, tires are made from rubber, and they are cylindrical in shape, rolling as they move. Tires determine their direction of movement through rolling. If they do not roll, tires are just masses of rubber, and only God knows the direction they would move in. Let's check what happens if the four tires are locked. No one can control the direction in which the tires move. Let's now check a case where only the front tires are locked. As previously mentioned, a non-rotating tire will not move in that direction even if the steering is turned. It's chilling to imagine if what we collided with wasn't a traffic cone but something else. ABS controls tire lock to prevent the steering from being ineffective. Before explaining ABS, let's review the mechanism of the brake system. When the brake pedal is depressed, the piston inside the master cylinder creates brake fluid pressure. This brake fluid pressure pushes the piston in the brake caliper, and the piston presses the brake pads and clamps onto the brake rotor. The ABS system is equipped with an ABS unit between the master cylinder and the brake caliper. The actual ABS unit has 4 circuits, but this video simplifies the explanation to only the right front and right rear circuits. Each wheel is equipped with a wheel speed sensor that constantly measures the wheel rotational speed. When the driver depresses the brake pedal, the brake fluid pressure generated by the master cylinder is applied to the pistons of the brake calipers. This activates the brakes and decelerates the tires. At this time, if the right front tire begins to slip and its rotational speed becomes slower compared to the other wheels, the control unit takes control of the right front brake. First, within the hydraulic circuit of the right front brake, the open inlet solenoid is closed, and the closed outlet solenoid is opened. As the brake fluid pressure from the master cylinder is cut off, the brake fluid pressure that was acting on the front brake caliper is released into the accumulator, causing the right front brake to be released. The hydraulic pressure stored in the accumulator is returned to the master cylinder side by the pump. Next, the outlet solenoid is closed to maintain the right front brake in a non-operational state, and it waits for the rotational speed of the right front wheel to recover. Once the rotational speed of the right front wheel recovers, the control unit opens the inlet solenoid. With the brake pedal still depressed, the brake fluid pressure from the master cylinder is once again applied to the right front caliper, generating braking force. If the rotational speed of the right front wheel slows again, the aforementioned process is repeated. In the latest ABS systems, this operation can be repeated approximately 50 times per second. The first passenger car to adopt an ABS system was the Ford Lincoln in 1970, featuring a system called SureTrack that operated only on the rear brakes. In 1971, Chrysler adopted the SureBrake for the Imperial. The system operated on all 4 wheels. These 2 systems were electro-operated, and could be referred to as analog-controlled ABS. The world's first modern electronically controlled ABS was introduced by Mercedes-Benz in 1978 for the S-Class. Nowadays, this brake control technology is utilized not only during braking but also in various other situations, including controlling wheel spin during acceleration, managing understeer and oversteer during cornering, enhancing cornering stability, and restraining speed during steep descents. Thank you for watching. If you enjoyed this video, please consider subscribing to our channel. We'll see you in the next video.